Here's an example of drawing the first and second derivative graphs based off a graph of a function. So when you look at this function and you're trying to figure out what the first derivative graph is going to look like, look at all the qualities of the function that the first derivative gives you. We know that first derivative can tell you where mins and maxes are and where the function is increasing and decreasing. So when you look at this original function, you're going to look for the mins and maxes. We have a minimum at x equals -1, which means the first derivative goes from negative to positive. We have a max at x equals 2, so we know the first derivative must go from positive to negative. That's the definition of a min and max. So those are the two key points. So when I jump over to draw my first derivative, I'm going to identify those points, -1 and 2. And the actual graph at -1 must go negative to positive. So negative means you're below the x-axis, positive means you're above the x-axis. And then at 2, it has a maximum, so the derivative goes from positive and then back down to negative. So that's it. For the second derivative, we're going to look at concavity. Now, it's very hard to tell or impossible where the concavity changes on a graph, but you can eyeball it. So if you're looking at the original function, it's concave up from here to about here, and then it goes to concave down. So the point of inflection looks to be about 0.5. Now, concave up means second derivative positive. Concave down means second derivative is negative. So when you're graphing the second derivative, 0.5 is the key point where it changes. That's the point of inflection. And we know the second derivative graph must go from positive, so above, to negative, below. And that is it. The next video, I'm going to show you how to look at graphs based off the first derivative.